Hi, my name is David, and today I'll be leading a workshop about data science, a growing interdisciplinary field in today's era of computing. So for this workshop, I'll be just going over three things about data science. The first one is that I'll introduce what data science is, the entire data science process, the cycle itself, and why it's such an important field in the modern era. And the second thing I'm going to go over are, just some two real-world applications of what data science could do. And there's many real-world applications that data science can do. They have certainly made an impact in almost every industry, from healthcare to sports and government to education. So specifically, I'll just be talking about what impact data science has made on education and smart cities in general. And finally, I'll just be going over the important programming languages useful for programming data science tasks, and some useful ID recommendations that help making reading and analyzing and exploring data a lot more easier. Along with that, I'll also be doing a simple demo of a data analysis using Python on Jupyter notebooks. So anyways, let's just go over the one question. What is data science? Is it a new kind of science, or is it just a fancy name for statistics? Well, for one, it's not really a fancy name for statistics, obviously. Well, as you know, if you do a simple Google search on the definition of what data science is, it'll most exactly say data science is about the extraction, preparation, analysis, visualization, and maintenance of information. It is a cross-disciplinary field which uses scientific methods and processes to draw insights from data. Typically, what that means is that you extract large sets of data and analyze it to develop data-driven solutions, which then which then leads you to present your findings to organizations and higher-ups who would make the best decision based on your findings. In other words, data science is all about doing data analytics and using machine learning algorithms to extract useful information and create insightful solutions. And mainly when you're analyzing data, you're you're basically analyzing quantitative and qualitative data. And that's what really separates itself from statistics. So, when getting to data science, there's a specific process when it comes to performing an EDA or just creating a software AI. This is this is to many other people known as the data science cycle, or what I like to call it, the meaty process. So the first step obviously is understanding the problem. So the first step, you have to ask yourself questions about the data that's being collected or being uncollected to gain a better understanding. For example, how much or how many, which group is being analyzed, which category, etc. By the time you achieved all that information, you not only identified the central objectives, but you've also identified the variables that need to be predicted. The second step is data mining. Now, data mining may sound familiar. It's pretty much all about gathering and collecting data. The difficulty in this step varies because it usually depends on how the data is collected. If it's all necessary, if all necessary data is packaged and handed to you, boom, easy. You're done with this step, that's it. But if it's in a database, which is, as you know, is an organized collection of data, you can query the data using the SQL query language or manipulate it using pandas, which, as you know, is the data frame library in Python. If, however, there's no data, there's none of that data you can find, then you'll obviously need to scrap it. One popular way the data scientists scrap for data is to track user data using countless data tracking tools, such as Google Analytics and all of that, and all sorts of different analytical tools. The third step, which is to many data scientists the hardest step, is cleaning the data. This is a time-consuming process because there are various scenarios in which a data set requires cleanup. Data could have inconsistencies. where some rows could be labeled 0 or 1, and others could be labeled no or yes. Even data types can be inconsistent. For example, the zeros in your data could be classified as an int data type or a string data type. So you'll definitely have to fix those kinds of errors. Another issue in this step is the presence of missing data, where sometimes you have a lot of errors in model creation and training due to a lack of data. There are two ways you could go about fixing this. Either you just ignore the missing data entirely, or you can do something called average imputation, which replaces missing values with the average of all the other instances. It's not the best way to go about it, but it's usually like an alternative you could go for. Then going towards the fourth step, once you have like a sweet, clean data set, now it's time to get started on analyzing it. Data exploration is all about brainstorming things, as well as just exploring the data itself. It's where you look up patterns and biases within your data. You could analyze a segment of data using pandas, plot histograms and distribution curves to study trends, and create interactive visualizations that tell a story about the data given to you. This kind of activity is known as exploratory data analysis, which would be a great first-time project for any programmers wanting to get into data science. Now for the next step, once you gain more knowledge about the data, you go through a process called feature engineering. In this process, using domain knowledge to transform your raw data into features that represent the business problem you're trying to solve. Usually there are two tasks performed in this step. The first part, feature selection. The process of cutting down the features that add way too much complexity and uselessness to what you're trying to solve. The second part is feature construction, where you create new features from the ones you already have, or merge multiple features to make them more informative by taking their sum, difference, or product. Once you've finally created the features you need, the next step is predictive modeling. This is where machine learning is finally being utilized in your data science projects. This is when you train your model in order to evaluate the success of your features. One example is a regression model, where metrics using coefficient determination. Wait, I'm sorry, hold on. Yeah, sorry. So anyways, you can use various like regression models like the regression model, the mean square error model, the average absolute error model. Like there's all these different there's different like models that you can use to test your features. And once it's trained, it's also important to evaluate its success of your model, either using a train test split or k-fold cross-validation. Now, once you get over the complicated process and all that, the final step of this data science cycle is data visualization. Now, if you remember from the last slide, I talked about how you could mess around with different data visualizations in order to see some depictions of data. You're pretty much doing the same thing here, except with the ultimate goal of communicating that data in a simple yet effective and visually pleasing way. You're pretty much creating visualizations that you would think would best help describe what you found out and what results you came up with. I'm not going to go deep into that now, but there are some ways to do data visualizations, such as using Python libraries like matplotlib and Seaborn, or using JavaScript itself, to create some majestic data visualizations. Like data visualization to me is like the coolest part because it's kind of like art, except rather than using paintbrushes or Microsoft Paint, you're basically using data to create visualizations. And that's cool. You can be your own artist. So why is it important? Like what makes data science such an important area? Well, that's because data is the new oil. Corporations themselves are swallowing so much data. Like they're just chugging so much from users and just collecting so much data. It creates this thing called big data, which is like it's a magnificently huge data set that corporations have. And right now there's a huge shortage of data scientists who can, for one, synthesize huge amounts of information from multiple sources, two, derive new insights, three, convert data into actionable information, and four, articulate their findings to the higher ups and all that. Like for example, Google processes over 20 petabytes of data daily. Like that's like a lot of data, like enough to like fill up the entire ocean, in my opinion. So like now we overall talk about the concept of data science and why it's such a big deal. But there's probably a lot of you wondering like what real effect does this have on the real world? Which is why I'll just be going over the two applications of data science to see what impact it has in each different area. The first application which I talked about before is data science in the area of education. With schools, colleges, and universities having an enormous amount of student data, and of course the student data can go from academic records, results, grades, etc. to handle. Analysis of this data can actually help educators find advanced ways to enhance student learning. One of the use cases is improved adaptive learning, where you supply a singular yet personalized experience for every user through customized content, real-time feedback, and resources. For example, in UCR with big data, professors can discover the abilities of students and use optimal teaching techniques according to them. Another use case is to improve students' performance, where you can analyze a student's performance in schools to make changes in a way that helps benefit the student towards solving their problems. For example, the performance of a student is becoming poor day by day. Big data and data science in education can help teachers identify the reason behind that and help the student overcome their problems. The second application, which is a very deep, it's a very deep way of using data science, so I'm not going to go into it fully, but it's mainly data science in smart cities. Mainly smart cities use information technology devices to fetch data and efficiently process it for implementing it in a particular area. Smart city sensors and connected devices actually collect data from various smart city gateways installed in a city and then analyze it for better decision making. For example, you can analyze the data full of road incidents to reduce the number of road accidents and congestion and help drivers find a parking spot. Very cool stuff. Like you guys should research this more. Data science smart cities can actually help solve a lot of infrastructural problems. So now we talked about data science, this applications of it. But so I'm gonna go over and talk about some of the top programming languages you can use when it comes to data science. The first language, obviously, is Python. It's a very powerful object-oriented language. It's very dynamic, it's easy to learn. There's simple syntax and declaration. There's faster development and processing. And it's best for machine learning. It's great for machine learning, it's great for AI, and it's perfectly suited for data manipulation and visualization. There's a wide range of data science libraries. You got NumPy, you got Pandas, Matplotlib, Seaborn, Plotly, scikit-learn, PyTorch, TensorFlow. There's so many data science libraries. It's literally why Python and data science are married to each other. That's the reality. The second language I'm gonna go over is R. For any of you guys not aware, R is also an object-oriented programming language, but it's actually built by statisticians. So it's actually a statistical analysis language. It primarily handles statistical analysis and graphics, And although it is different from Python, it does offer efficient handling of data and additional analysis tools like time series analysis, clustering, and statistical tests. And it does allow many options for plotting and visualizations, such as ggplot2, lattice, and plotly. And like Python, it has a huge active community of contributors, making R better day by day. And then the third language that each data scientist should know, and usually this comes to when you're messing with relational databases, it's called SQL, otherwise known as structured query language. It's a standard language for storing, manipulating, and retrieving data in a relational database. For anyone who doesn't know, a relational database is where all data sets are stored. And so it's basically where it's like if you have like a database is like a library, and each data set is a book. So that way, that's how databases are formed. Basically, SQL allows you to create new databases and create new tables in existing databases. So not only can you make data sets, you can even create databases. To manage a relational database, you would sometimes need to use an RDBMS, or otherwise known as Relational Database Management System. There are multiple RDBMS systems that are out there. One of them is Oracle Database. The other one is Microsoft SQL Server, and I think another one is MySQL. So there are also other notable languages too. The first one is JavaScript. Obviously JavaScript is built for web development, but it can also create some really good majestic data visualizations. And it also does support modern day machine learning libraries like TensorFlow and Keras. Another language is MATLAB. Not necessarily like a favorite for data scientists, but it can definitely handle mathematical and statistical problems with ease. And it does execute operations such as matrix manipulation, data function plotting, and etc. So definitely things that data scientists do is mess with matrices and vertex. The next language is Java. Not really popular, but it does offer tools such as Hadoop and Spark and all that. And the last one I'm going to mention is C/C++, which it's not really the main language. Like it's not super popular, but it is definitely used to build tools for data scientists. So if you want to build like a plotting tool or just a simple analysis tool, you can definitely build out with C++. So now we went over the programming languages. I think it's a good idea to tell you which recommended IDE you should use for Python. If you want to use Python for all things, I'm sorry, wait, for Python, R, and SQL. So if you want to use Python for all things data science, including machine learning, the best IDE to use is Jupyter Notebooks. For anyone who's familiar with Jupyter Labs and like messed with it during the CS10 class, CS10 series and all that, Jupyter Notebooks is pretty much the same thing, except you don't really need an internet connection to access your notebooks. It is definitely a web-based user interface that can be used to combine software code, computational output, and exported text and multimedia resources into a single document. It's so good. It's the reason for data scientists, it's the perfect tool for doing data exploration and visualization. If you like to only do statistical data analysis and you're interested in R and all that, well, there's one popular IDE for using the R language. It's called RStudio, and it includes a console, a syntax highlighting editor, and it supports direct code execution, as well as tools for plotting, history debugging, etc. If R is the only language you want to learn, then RStudio is perfect for you, as it just gives you all the R libraries and the tools needed to do some lit data analysis. If you're already using Jupyter Notebooks, though, you could definitely implement the R language into Jupyter as well. Now, for SQL, it can vary sometimes because it depends on what relational database management system you could use. The SQL language can change a little bit depending on which relational database management system you use, which is why it's okay to use any relational database you want. Some notable ones you could look into are Oracle Database, Microsoft SQL Server, and MySQL. So now that we went over everything, I think now is a great time for a demo. We're pretty much going to be doing a mini analysis on 911 calls. Now, you guys might be wondering, why are we analyzing 911 calls? Who cares? It's fun. Why not? So obviously, we'll be using the Python language, and the IDE I'll be using is Jupyter Notebooks. But if you guys want to, you can use any IDE you want, as long as it's useful for Python and all of that. So then the next thing, I actually created a link for you guys to download the entire folder and all that. If you guys want to visit the data set and all the code and all this stuff, I'll post it at the bottom. I'll post it into chat real quick. How do I do this? Okay, sweet. Actually, I don't know how to bring up chat. Okay, I'll post it in chat later. But yeah, I basically created this GitHub repo where it contains all the 911 calls, data, and all that. So actually, wait. Hey Roy, is there a way to pull up the chat? Because I can't find
Yeah,
a way.
no. So when you're screen sharing, I think it should be at the upper center of the primary screen.
Yeah. Oh,
And then
right, there you
yeah,
go. Oh, sweet, you posted it.
yeah.
Nice, thank you.
Yeah, no problem.
All right, great. Whew, okay, so that's covered. We'll be doing some cool data analysis. Let's do it. So the first thing you want to do is that you want to import libraries. So the required libraries you'll need, there's only 4 Python libraries you definitely need. The first one is NumPy, the second one is Pandas, and it's Matplotlib and Seaborn. Now, there's various ways you can install the libraries. If you're using the Anaconda platform, then you'll definitely want to do conda install NumPy, conda install Pandas, and then just follow the stuff and just put it into the terminal. If you're using other IDEs, however, then you could also just do pip as well. You can definitely do pip install NumPy, Pandas, Matplotlib, and Seaborn. So yeah, if you guys need time to install it now, I can give you guys time. You guys can just let me know in the chat if you guys downloaded it. It'd be great. Okay. Is everyone good? You guys want me to move on, or?
Conda might take a while to install. I think it's like 500 megabytes. Yeah.
Okay, that's fine. I mean, Do you want to go right ahead, Roy, or you want me to just wait for you?
Oh, it's really up to you. Yeah, I think it's really up to you. However you want to
Yeah.
proceed, it's your workshop. Yeah.
Okay. Um, I'll give it another minute, like just so you guys can catch up. So yeah. Usually the download process takes a while, so yeah, I should have actually accounted for that, but that's fine. I mean, I can wait. Okay, so I think everyone got enough time, so I think I'll move on. I'll actually switch to Jupyter Notebooks right now. So, excuse me. Okay. So, I think so. The first thing you want to do is that you want to import NumPy and pandas. So I'll do that first. So you want to do imports. The first thing you want to do is do import NumPy as NP. So I'll do it right now. And then you want to do import pandas as PD. Okay. So you guys might be wondering, what is NumPy and what is pandas? Well, just to show you, NumPy is pretty much a linear algebra library for Python. Like usually like the first thing you do when like learning as data scientist is learning what linear algebra is. So it's pretty much where you do NumPy is where you basically create multi-dimensional array objects, and you do various derived objects such as masked arrays and matrices. And there's assortments of routines for fast operations on arrays. And if you want to import it, the best way to import it is doing NumPy as NP. The next step is that you want is pandas. As you know, pandas is a Python data manipulation and analysis library. This is where you kind of like this is where this library is useful for manipulating your data as well as like analyzing and exploring your data as well. It's known to have two data structures, series and data frames. A series is a one-dimensional labeled array capable of holding any data type. And so this is one example of it. You can see here. It's kind of like using, you first of all create a dictionary, and a dictionary can be used as a series. And that this series basically creates this one-dimensional array that's capable of holding any kind of data type. The second the second data structure is two-dimensional. It's basically called a data frame, and it's a two-dimensional labeled data structure with columns of potentially different types, like a spreadsheet. So data frame is kind of like an Excel spreadsheet. So it's pretty much like, okay, like on one column you have one and two, and for all the rows you have A, B, C, and D. And this is like the perfect example of it right here. So I'll go back here. So then the second thing you want to do, the next step is you want to import matplotlib and seaborn. Now matplotlib and seaborn are both visualization libraries. Now I might be wondering, why do you need both of them? Like, what need is there to have both of these data visualization libraries? Well, if you think about it, seaborn is actually, well, if you think about it further, matplotlib is the granddaddy of It's a granddaddy library of data visualization in Python. It's if it sounds familiar, it is actually similar to MATLAB, but it's built for Python, and it's pretty much a NumPy extension. It is easy to get started for doing simple plots and supports custom labels, and it offers great control and quality output. So obviously the first thing when it comes to importing matplotlib is that you want to import the pyplot version of matplotlib as PLT, and you also need this inline, this percentage matplotlib inline. The reason why this is useful is that it actually, once you actually like create a command for making a plot, it compiles the plot immediately, like in line, which is really, really cool and really useful. However, this is only possible when doing so on Jupyter notebooks. So if you're not using Jupyter notebooks, you can always do plt show. You can always use a command called plt.show, which you can use at the end of all plotting commands. Like, it's very useful. So a good alternative, to put it that way. So now I'm going to import Seaborn as SNS, and Seaborn, as you know, it's basically when matplotlib had a baby. And it's a Python data visualization library. It's based on matplotlib, except it provides a high-level interface for drawing attractive and informative graphs. So you can do distribution plots, categorical plots, matrix plots, grids, and regression plots. You can do all of that with Seaborn, and it's really, really cool, and it's really useful. So if you want to import it, you can always do import Seaborn as SNS. SNS represents the library Seaborn. There we go. I imported both of these libraries. I also should do matplotlib inline. So just I do like percentage matplots lib inline. Okay. So once you have that, now you're ready to, now it's time to actually read the library. So in order to read the library, you have to create a data frame object. It's called df. In order to basically add the data set into the data frame, you have to do df gets pd dot read csv, and then you put into the parameters 911 copy 1 dot csv. Basically what this will do is that it will basically put the data set into the data frame. So here you go. Once you have that, you should be able to export the data. So you can do something like df info, which should tell you about what's in the data set. So if I do this, you can see here that it tells you the columns, what data type it is, and definitely what data types there are, such as float, int, and object. So if you want to get like a full idea of like what the data set actually looks like, the best thing you could do is do df head. And so what df head does is that it actually gives you the first 5 rows of the data set. So if you want to look at the first 5 rows of the data set, all you have to do is input 5 into head. And what it does is it shows the first 5 rows of the data frame. So all you do is you have to run this, and there we go. You can see your latitude, longitude, description, zip code, title, timestamp, town, place, and address. You can get all this information just by doing df head. So now we just have to, so now we got a full idea of what our data looks, for what our data basically contains. Now we can go over like what are the top 5 zip codes. if you're asking yourself that question, so as you know, you have zip code right over here. So if you want to look at the top 5 zip codes, you'll have to do df dot value counts. Sorry, I have bad typing. And basically what this will do is that it will actually look at the top 5 zip codes. So you can see here, the zip code 19401 is the most popular zip code in this data set. And yeah, basically that's pretty much how you could look for the, like, which is the most popular part of the data, which is the least popular part of the data, very useful stuff. And then if you want to look up the top 5 townships, so I can do is you can just do df brackets twp closing bracket, and then you do dot value counts function dot head with the parameter 5, and you should be able to get the top 5 townships, which is Lower Marion, Alvington, Norristown. So yeah, this is how you can look up the top 5 townships. Now, if you want to look at now you might be wondering, like, how many unique title codes are there in this data? In order to look at how many unique titles there are, you can do df bracket title dot n unique, and it will basically count how many unique titles there are. You can see there's about 110 unique titles. So, okay, now you basically like explored the data a bit. You've seen which is the top 5 townships. You've seen all of that. And now you want to create some new features. So in order to do that, up here it says in the title column there are reasons/departments specified before the title code. There's EMS, fire, and traffic. Use apply with a custom lambda expression to create a new column called reason that contains the string value. So what's saying here is that it wants you to create a new column within your data set called, not data set, data frame called reason, which basically like looks up why basically are you calling 911? Is it because there's a fire? Is there a traffic congestion? Do you require an EMS? So in order to create a new feature, all you have to do is simple. You just have to do data frame brackets reason gets df title dot apply lambda, or wait, sorry, did I spell wrong? Yeah, it's supposed to be lambda. There you go. And then you do title dot split zero, and there you go. So I'm not going to go too deep into what lambda is all about, but basically what this line does is that it creates a new line, it creates a new column for reason. So I should be able to compile that. So now you create a new feature. Now you can look up what is the most common reason. So if you want to look at the most common reason, you can do df reason dot value counts. And you can definitely look here. Oh, wait. Huh, okay, well, it definitely shouldn't crash like that. But, oh, okay. you can definitely see here the different reasons and all that. So now like you can, actually let me fix one thing real quick. Okay. So I'm pretty sure that shouldn't break. Oh, that's why. All right. There we go. Okay, it's fixed. Yeah, sorry, there was a little bit of an error. But anyways. Okay, sweet. So now you actually create a new feature. So let's actually create some cool plots, you know? So let's so now like the first thing we can do is that we can create a Seaborn to create a count plot of 911 calls based off of reason. So you definitely do sns.countplot x gets reason. So what it says is that your x variable will be reason. The data will be the data frame that you created. And let's just say like for the palette, it can be, I'll basically create a palette. I'll use a palette called Viridis. The palette basically like it creates the color scheme of your plot. So let's compile this. Boom, you actually got this really cool plot that you actually generated. So what it says here is that yeah, EMS has the most has most number has most number of 911 calls as reason. So now you actually create your first plot. You should be able to do all sorts of things. Okay. So definitely let's focus on the time information now because time information is pretty useful. So I think the first thing we should go over is what data type of the object is the timestamp column at. You just do this, type df timestamp dot I location parameter 0. The type function should be able to give you what data type the timestamp column is. As you know, it's str. So once you have that, like, okay, you should have seen all these timestamps that are still strings. Then you use PD to datetime to convert the column from strings to datetime object. So it's asking us to create a datetime object. In order to do that, all you have to do is do df timestamp gets PD dot to datetime df brackets, then you put timestamp into the parameter. And what this should do is that it should convert the time all the strings in a timestamp column into datetime objects. So now you can grab each specific attribute from datetime object by calling them. For example, if you want to find the hour for each time, then it could basically give you the hour of the time object, which is pretty useful. So now you can basically use the Jupyter's method to pretty much create 3 new columns. So now you're creating 3 new columns, and they're called hour, month, and day of the week. So I'm not going to actually do all the coding right now, but I'll paste the entire code to you. So basically like what's happening here is you're creating a new feature where you're creating the hour column by taking what's in timestamp and applying the time.time.hour to create the hour column. And you're basically doing the same thing for a month. For a month, you're grabbing a part of the data from the timestamp column and you're applying it to create the month. Same thing here with day of week. So once you have that, we should be able to I think the next thing you could do, like, so let's say we want to finally make some plots about the months and all that. Sorry, hold on. You want to make a count plot for the day of the week column? Well, in order to do that, we first need to clean up the data. So the next thing it's asking you is that it wants you to use the map function to create a dictionary. As you know, a dictionary is actually kind of like a list in Python, except a dictionary can be based off whatever data type it actually is. So I'll do this first. Once you have that, you should be able to create a day of the week column, which will definitely do it. It'll definitely create the column based off what's in the D map. Now, once you have that, you should be able to create a count plot based off of the day of the week column. So in order to do that, you do sns.countplot. Get the x, which is, as you know, is the x variable, will be day a week. And then the data you'll be using will be df. And you want to plot your data based off of reason. And let's just say for the sake of color scheme, you can do Veriduce. That's what it's called? Yeah, Veriduce. So palette gets so once you do that, you can finally run it. And then you'll get this interesting bar plot of all the different you get this count plot of all the different reasons for the 911 calls for each of the days. So it's very cool. So you get to see like, okay, when is like fire most popular in one of the days in the week. So now we should do the same thing for a month. For a month, all you need to do is I'll just copy this. Now basically do month. So the x variable will be the same thing as the day of the week count plot, except you'll be changing the x variable to month. Otherwise, the data stays the same, the hue stays the same. So once you do that, you finally realize, oh, okay. So definitely EMS 911 calls are most popular in the first month and the 7th month. Wow, crazy. Okay. And then for some weird reason, traffic is popular in January. I wonder why. Probably like snowy mountains, like super bad vacation traffic. There's crazy reasons for why it is, but we can go deeper into that later. Sadly, like I won't be able to do the entire thing. Like there's a lot of stuff to go over, but if you want to, you can go to the GitHub link that Roy should have sent you in the chat, and you can just go to that GitHub link, fork it, and you can just like do the entire data analysis by yourself. You just want to see how the plots are. But yeah. But anyways, yeah, if you guys like stayed with me and like did all the data analysis and data exploration and all that, well then congrats. You actually done your first data analysis, you know? Yeah, John Wick is proud of you. Good job. So yeah. So definitely there's a lot of stuff. There's a lot more things you can learn besides what you just learned today. There's definitely other libraries and data sciences tools that you could use. The first one obviously is scikit-learn, and there's obviously TensorFlow. These both are actually machine learning libraries that you could use to help create machine learning models to test your data. And there's also you can also do some plotting with ggplot2, which is in RStudio, which help create some pretty great plots as well. So yeah, obviously there's a bunch of resources you can use. If you guys want, there's you can definitely go check out this cool article about the data science lifecycle. It's what I learned like a long time back. Anyways, yeah, there's all of these like cool docs and all that. And if you guys want to learn machine learning in your own time as a hobby, you can definitely check out this machine learning course by Jose Portilla. Is what I actually took last year when learning data scientists. He's a very great instructor, and he really goes deep into like, okay, like what data scientist is and what do you do and what do you analyze, what do you explore. So yeah. Anyways, yeah, that's all I have. Thank you. If you got any questions, you can always ask me on Discord. This is my username right over there. If you want, you can contact me there. Otherwise, yeah, have a great day.